lecture number 9. Last time we have on ionization energy, and we discussed how to find.
Sir,
Yes.
could you send me these lecture videos somewhere?
Sorry, I don't understand. I could not understand. Can you tell me again?
I was asking if you could send me these lecture videos. If you can easily.
Okay, sure. Yes, sure. After the completion of the chapter, I will send you all, right? I will share the folder. Okay.
Okay.
I am also sharing this PDF, right? But after the completion of the chapter.
Okay. Thank you.
This is 2008. Okay, so we are on the topic ionization energy and how to find ionization energy. And after finding the ionization energy, we have moved to AR, right? This is ionization energy. This is a few past paper question. Hamza, what is ionization energy?
Ionization energy is the amount of energy required to move one electron from an atom into a gas, from a gaseous atom to a gaseous ion.
Very good. Gaseous atom to form gaseous ion. Very good. So, okay. Now next question. Next question. This is lecture number 9. This is lecture 9. Now, question, what is electronic configuration? What is electronic configuration of Mg2 plus? So as we have discussed, first write the normal electronic configuration of magnesium. So we know that magnesium is 12. So anyone can tell me the electronic configuration of magnesium? Yes.
282, the normal one.
Okay, 1s2, 2s2,
Oh.
2p6, right? Then 3s2. Then 3s2. But the question is magnesium 2 plus. 2 plus means remove 2 electrons. So we remove 2 electrons from valence shell. Third shell is our valence shell. So the new electronic configuration would be 1s2, 2s2, 2p6. So this is the electronic configuration of magnesium 2 plus. Now next question, 9701, variant 22, February, March 2022. So 2022, February, March. February, March, variant 22. Question number 1. Question number 1. Question number 1. Now question number 1. This is 2022, February, March. Question number 1. This is the question. Construct an equation to represent the first ionization energy of oxygen include state symbol. Yes. What is the equation for the oxygen to remove one electron? Yes, Rania and Hamza. How can we write the first ionization energy of oxygen atom? So oxygen.
It go from O to O7 plus and then E minus.
Okay, O gaseous to O plus 1 gaseous plus
Yeah.
electron. So whenever you remove the electron, positive charge is developed, right? So positive charge on oxygen. Now question number 1. Part 2. Explain general trend of first ionization energy across the period 2. Across the period 2. Yes. State and explain the general trend in first ionization energy across the period. This is for 3 marks. Yes, anyone? 3 different points across the period. Yes. Can anyone tell me across the period proton number increases or shell number increases?
Across the period, the shell number increases.
Across the period, shell number increases.
Sorry, across the period, the proton number increases.
Proton number increases, right? So first steric. First steric means first mark. Across the period, proton number increases. Across the period, proton number increases. Proton number increases. Nuclear attraction increases. Nuclear attraction increases. Nuclear attraction increases. nuclear attraction increases. Now, what about the shell? Shell increases or remains same?
Remains the same.
Remains same. So shielding remains same. Shell remains same.
Wait, sir, if the number of shells increase, the shielding effect also increases, right?
Exactly. Down the group, number of shell increases, shielding increases, nuclear attraction decreases, ionization energy decreases. But
Okay.
across the period, proton number increases, nuclear attraction increases, shell remains same, shielding remains same. Shielding remains same. Shell remains same, shielding remains same. So ionization energy increases. Ionization energy increases as more energy is required to overcome
More protons. Sorry, more electrons.
this attraction. So if you need to overcome this attraction to remove an electron, you must need more energy. That's why across the period ionization energy increases. Now next, explain why ionization energy A in figure 1.1 does not follow the general trend in first ionization energies across the period 2. Now look at, we decided that across the period ionization energy increases, but you can see that this
The
is
ionization
increases.
energy here varies,
Yes,
right?
this is increases, but from nitrogen to oxygen, it
It decreases.
decreases. You know that BB aminops, right? This is BB, this is NOPS. So this is nitrogen and oxygen. These are nitrogen and oxygen. So which phenomena will you write here? Yes,
Which phenomenon?
spin pair repulsion.
Oh yeah, spin pair repulsion.
Spin pair repulsion. Because in p electron, if electrons are paired, then more energy is required. Less energy is required.
All right, sir.
Okay. Now first answer. Now first answer. Explain why ionization energy A. So A is oxygen. Yes, A is oxygen. A means oxygen. Oxygen has paired electron. Paired electron in 2p. Now look at the oxygen. This is oxygen. Oxygen is 8, 1s2, 2s2, 2p4. 2p4. 1, 2, 3, 4. So electrons are paired. So oxygen has paired electron in 2p. This is 2p. While nitrogen has Nitrogen has all unpaired electron. Unpaired electron. This is for 1 mark. For second part, you know that paired electron repel each other. So second part, paired electron repel each other. Paired electron repel each other. Paired electron repel each other. Known as spin pair repulsion. Known as spin pair repulsion. So due to spin pair repulsion, third point, due to this repulsion, due to this repulsion, due to this repulsion, less energy is required. Less energy is required to remove an electron. To remove an electron. So this is all about second part. Now, last part of the question. This is the last part. This is the last part. So element E is in period 3 of the PI table. The first 8 ionization energy values of E are shown in the table. Deduce the full electronic configuration of E. Explain your answer. Now, can you tell me which one? Can anyone tell me the group number? Where is the big jump? Yes.
Second.
Where is the big jump? After second or after third?
Third, yeah, after third.
After third. And the period number is 3. Period number is 3. Group number is 13. You can easily identify the element. Now open PRD table and find the element. Period number 3. Yes. Here mention period number 3. And group number is 13. Group is 13. Period is 3.
Is it gallium?
Yes. Can you identify the element? Group number 13 and period 3.
Gallium?
Yes. Can you tell me the name of the element?
Third, is it gallium, GH?
No. Look at again. Group number
Oh.
13. Group number 13 means 3. Group 13, period 3. Sodium period.
Yes, aluminum. I was looking at it well.
Aluminum. Okay. Element is aluminum. Element is aluminum. So write full electronic configuration of E. So you know that aluminum has 13 electron. Now you can easily write the electronic configuration of aluminum. So 1s2, 2s2, 2p6, 3s2, and then 3p1. This is the electronic configuration. And reason is the same. Because big jump between third and fourth. Reason is same. Big jump between third And fourth, ionization energy. Which indicates valence electron and group number. Group number. Valence electron 3 and group number is 13. Because after removing third electron, ionization energy suddenly increases with a big jump. Valence electron 3. Any question? Any
Not
question?
really.
Okay. Any question regarding Hamza?
No, sir. I think I understand it.
Okay. So this is all about first chapter, right? So we have completed ionization energy. We have completed how to find the AR. We have completed all ionization energy effects. This is electronic configuration. These are orbitals, type of orbital, electrons. These are the numerical. Okay. So can I move to past paper question right now? Or should I start new chapter?
Sir, is it okay if we can do the past paper questions in the next class because
Past
I
paper.
have, I still have to revise a bit.
Okay.
Me too, sir, because I wasn't really there for the previous lectures.
Okay, I will send you the lecture as well as the PDF of the lecture. So move to the past paper question, right?
No,
And
what I'm
I
saying,
will. Sorry, can you?
what I'm
Mhm.
saying is, can we do the past paper questions in the
Yes,
next
yes.
class? So like, not
In
not
this
not
class,
right now. Can we just
in this class or the next class?
Next
in the
class.
next class?
Okay, okay, okay. So I am going to start new chapter, right?
Yeah,
Second
sure.
Okay.
chapter, chemical bonding, right?
Okay, sir.
Okay.
Yeah, I'd really appreciate it if you could send me the lectures so that I can also catch up.
Rania, don't worry about it. Inshallah, I will send you
Okay.
by tonight. Inshallah. Now this is second chapter, chemical bonding. Chemical bonding. Now first look at the syllabus. If I have here a syllabus, yes. Chapter number 2, chemical bonding. So in physical chapter, in physical chemistry, we have 8 chapters. So we have completed atomic structure, and the second chapter is chemical bonding. This is atomic structure. Yes, this is chemical bonding. So we have 3.5. So we have 3.6, 3.7. So we have 7 subtopics, right? 7 subtopics. So first is 3.1 electronegativity and bonding. So syllabus of first part of chemical bonding is yes, chapter number 3, but our chapter number 2, right? So this is the first part, right? Define electronegativity as the power of an atom to attract electron. So first topic is electronegativity, right? So what is electronegativity? Hamza, do you know anything about it?
No, sir, I have no idea.
Okay,
Electron. Yes.
okay. And Rania?
Me neither.
Okay. So electronegativity is the power of an atom to attract bond pair of electron, right? Let's suppose we have hydrogen and chlorine. So both share their electrons, right? So electronegativity is the power to attract this bond pair, right? Let's suppose electronegativity of chlorine is greater, so bond pair move towards chlorine. This tendency is called electronegativity. Are you getting my point?
Yes.
So electronegativity, what is electronegativity? Electronegativity is the power of an atom. It is power of an atom to attract bond pair of electron toward itself. This power is called electronegativity. Now these are bond pairs. These are bond pair. So bond pair move towards chlorine. So bond pair move toward chlorine. Bond pair move towards chlorine. So which one has more electronegativity? Yes, which one
Chlorine.
has chlorine? So electronegativity of chlorine is greater than electronegativity of hydrogen, because chlorine has more tendency to attract bond pair. So we have to memorize electronegative elements, right? Their electronegativity is very high. So write a DI. DI means doctor instruction, important point. DI means doctor instruction. or you can say important point, right? So always remember phone club. Phone club. So electronegativity of fluorine, these 5 elements have highest electronegativity. These 5 elements have highest electronegativity. These 5 elements have highest electronegativity. So electronegativity of fluorine is greater than oxygen. Similarly, electronegativity of nitrogen is greater than bromine. But these are top 5 elements having highest electronegativity. Highest electronegativity. Next point. Across the period. Now tell me again, across the period, proton number increases or shell number increases?
Proton number.
Okay, across the period, proton number increases. As proton number increases, nuclear attraction increases or decreases?
I think increases.
Increases
Wait.
because proton number increases, nuclear attraction increases. Okay, as nuclear attraction increases, power to attract a low bond pair increases or decreases?
Increases.
So electronegativity
Increases.
increases. So across the period, proton number increases, nuclear attraction increases, power to attract bond pair increases, hence electronegativity also increases. Now tell me down the group. Shell increases or proton number increases?
Shell.
Shell, the number of shell.
Shell increases. As shell increases, nuclear attraction increases or decreases?
Decreases.
Decreases because valence electron far away from the nucleus, right? So nuclear attraction decreases. Then power to attract bond pair increases or decreases?
Decreases.
Decreases. Hence, electronegativity decreases.
Yeah.
Alhamdulillah. Down the group, shell increases, nuclear attraction decreases, power to attract bond pair also decreases. Hence, electronegativity also decreases. Now we have, are you getting my point?
Yes, sir.
Okay. So across the period, electronegativity increases, down the group decreases. Across the period, down the group. So across the period, electronegativity increases, down the group, electronegativity decreases. Now another DI, Lena rule. Lena rule. This is my rule, right? Lena rule. Lena is my student, and Lena is derived from two words, lithium and sodium. Lithium and sodium. Now I am finding periodic table. Periodic table. So this is periodic table. This is Lena method. These are lithium, sodium. And these are remaining elements. Now you have Lena. Now draw vertical arrow. Make arrow just like tilted arrow. So always remember electronegativity of lithium. Always remember this DI, electronegativity of electronegativity of electronegativity of lithium is always equal to electronegativity of magnesium. Similarly, electronegativity of beryllium is equal to aluminum. Similarly, electronegativity of boron is equal to electronegativity of boron is equal to electronegativity of silicon. So always remember Lena method. So it is quite easy to memorize this exception. This is exception. Mohammed, are you getting my point, Hamza?
Yes, sir, I'm sure.
This is called diagonal rule. You can say that this is a diagonal rule, or you can say Lena method, right? So quite easy to memorize this. Now, Pauling scale. Pauling scale. Pauling was the scientist. Pauling was the scientist who quantified this attraction. No one can quantify any attraction. So affection is affection, attraction is attraction. But first time, Pauling quantify electronegativity. Do you know anything about Pauling scale? Yes.
No.
Okay. This is Pauling scale of electronegativity. So the first point is the most electronegative element, the most electronegative element is assigned a value of 4. The, the most electronegative element is assigned a value of 4, and that belong to fluorine. Belong to fluorine. Fluorine. Are you getting my point or not?
Yes, sir.
Yes.
Okay. So you can see that this is fluorine, this is chlorine, this is bromine, this is iodine, this is astatine. So look at the value of electronegativity. Fluorine has 4.0, chlorine has 3.0, 2 bromine 2.8, 2.5, 2.2. Now you can see that down the group electronegativity, yes, increases, decreases,
Decreases.
decreases, decreases. Now across the period,
Increases.
increases. So example is boron, carbon, nitrogen, oxygen, fluorine, boron 2, carbon is 2.5, nitrogen is 3, oxygen is 3.5, fluorine is 4. Now you can see that across the period, electronegativity, yes, Increases, decreases?
Increases.
Increases. Increases. This is Pauling scale, right? Now, importance of Pauling scale.
Sure, I'm writing these things down. Do we have to write the second one that you made? B, C, N, O, F.
Sorry? Can you repeat it again?
Yes, sir. I was saying if we need to write B, C, and O, F like in our notes.
Yes, you can write. This is boron, carbon, nitrogen, oxygen, fluorine. When you know the value of Pauling scale, you can easily identify the nature of the bonding, right?
Yes.
No need to memorize it. No need to memorize it. Just write it for your
Okay.
knowledge. Now, another DI. Find the difference of bonded electron, bonded atom. Find the difference of bonded atom. If the difference is, let's suppose here we have 0, here we have 1.7 or 0.4, here we have 1.7. So if this is the difference, difference of electronegativity, difference of electronegativity. If the difference is between the 0 to 0.4, it means compound is non-polar. We will discuss what is non-polar, right? If electronegativity difference is between 0.4 and 1.7, then the bond is polar. We will discuss what is polar. And if it is greater than 1.7, it means it is ionic. Are you getting my point or not? Now look at this
Yes, sir.
example. Now look at this example, right? Then we will decide what is ionic, what is covalent, right? Non-polar, polar means covalent, right? All are covalent. Polar, non-polar are covalent. Now look at the example HCl. Now find electronegativity difference. Do you know the electronegativity of hydrogen? I think electronegativity of hydrogen is 2 point something. Can you find the electronegativity of hydrogen from Google?
Sure.
Is it 2.4? I'm not sure about it.
2.2, sir.
2.2.
Uh-huh. Yeah.
Okay. So hydrogen 2.2
2.2,
minus
yes.
2.2 and chlorine is 3. So the difference is 0.8. Ignore negative sign, right? Ignore negative sign. Or you can write 3 minus 2.2. 3 minus 2.2. So 0.8. So can you tell me the nature of HCl bonding? polar, non-polar, or ionic?
It's ionic.
Is it more than 1.7 or between
Oh,
0.4 and
sorry.
1.7?
It's polar. Yeah.
Polar. So HCl is polar. Now next. Chlorine. 3 minus 3 is 0. So can you tell me? Either it is polar, non-polar?
Non-polar, right?
Yes, exactly, non-polar covalent. Non-polar covalent. Next is HBr. HBr. Bromine is 2.8, 2.2. Answer is 0.6. Polar, non-polar? It's polar covalent. This is all about electronegativity. Do you have any question?
No, sir. This is pretty simple.
Okay. Explain the factor influence the electronegativity of elements in terms of nuclear charge, atomic radius, and shielding by inner shell and subshell. So we already discussed here across the period. So compare electronegativity, compare or make the heading factors on which electronegativity factors on which electronegativity depends. Factors on which electronegativity depends. So first is
Proton
nuclear
number and
charge.
shells, right? Oh.
Exactly proton number or nuclear charge, right? Second is radius, and third is shielding. So first one is nuclear charge. Second is atomic radius. Third is shielding of inner electron. Inner electrons. Now first point. More proton, stronger attraction between nucleus and bond pair of electron. Nuclear charge, more proton, more protons. Stronger attraction. Stronger attraction between nucleus and bond pair of electrons. Number one. Number two, across the period. Number one, proton increases. Number two, nuclear charge increase. Nuclear charge means proton. Number three, nuclear attraction. Nuclear attraction increases. Fourth, electronegativity increases. Shell remains same. Shielding remains same. Are you getting my point or not? Beta, are you getting these all points or not?
Yeah,
Lamia?
yeah.
Okay, alhamdulillah.
Yes, sir.
Alhamdulillah. Okay. Now, atomic radius. Atomic radius. Closer to the nucleus. Closer to the nucleus. A stronger attraction between nucleus and bond pair of electron. Electron. Now next, same. Down the group. Down the group. A shell increases. B shielding increases. C nuclear attraction decreases. Nuclear attraction decreases. Electronegativity decreases. Do not consider proton number, right? Do not consider proton number when discussing down the group. Are you getting this atomic radius, or do you have any question?
Sir, I do understand, but like if you have a bigger, I don't understand, like if you have a bigger atomic radius, does that mean that how will it change
No,
electromagnetic?
okay, now listen. As you have bigger atom, so nuclear attraction between valence electron and nucleus, right? So as the atom's atomic size become bigger, valence electron become farther away from the nucleus. So this attraction decreases. So as the attraction decreases, pull of the nucleus decreases. That's why electronegativity decreases. But are you getting my point or still not? Nani, are you listening to my voice?
Yes, sir.
Sorry, sir, I couldn't hear you.
No,
Your
now
voice
listen again.
was kind of glitching.
Okay, no, listen. As the down, you know that down the group size increases, right? So as the size means a distance between the valence electron and nucleus, right? So as the distance between valence electron and nucleus increases, nuclear attraction decreases, because as you far away from the nucleus, nucleus attraction decreases. So as the nuclear attraction decreases, pull of the nucleus also decreases. So that's why electronegativity decreases. Anya,
Wait, sir, could you repeat that? I didn't hear your voice properly.
can I
What
move
was
to
your?
another? I think so.
Yeah, sure. I don't mind.
Okay. Now shielding of inner electrons, right? Now next point is less shells of electron between nucleus and the electron. It means less shielding. Less shell, less shielding. Less shielding, less repulsion. Less shielding, less repulsion. Hence stronger attraction between nucleus.
Sir, I can't see your screen, by the way. If in case
Okay. I am sharing again. Okay. Hamza.
I can see it now, sir.
Okay. Attraction between nucleus and bond pair of electron. Bond pair of electron. So it means as the shielding increases, electronegativity, as the shielding increases, electronegativity decreases. So it means electronegativity is directly proportional to nuclear charge. Nuclear charge. Electronegativity is inversely proportional to atomic radius. Similarly, electronegativity is inversely proportional to shielding, because as the shielding increases, electronegativity decreases. Are you getting my point or not?
Yes, sir.
Okay.
Yeah, sir. Yeah, sir, I got your point.
Next is, so we have discussed what is electronegativity. We have discussed factors on which electronegativity depends. Now, instead of explain the trend electronegativity across the period and down the group, we have discussed. Use the difference in Pauling electronegative values to predict the formation of ionic and covalent bond we have discussed. The presence of covalent character in some ionic compound will not be assessed. Pauling electronegative values will be given given if where necessary. So we have completed the whole section. Are you getting my point or not?
Yes.
Okay. Now I am finding few questions from the past paper of electronegativity, and then electronegativity past paper. Hmm, I think 2015. Name and describe the type of bonding with respect to find the between the particles with equal electronegativity. Describe the type of bonding with respect to between the particles with the. Okay. Now 9701. 9701. Variant 22. October, November 2015. 2015. October, November, variant 22. Yes. Question number 1. Yes, define electronegativity. Can you explain what is electronegativity for 2 marks?
The power of an atom to attract electrons to itself. But isn't this 1 mark explanation?
Yes, exactly. So can you tell me why 1 marks? Can you give more detailed answer? Yes, Mohammed. So always remember that electronegativity is the property of only covalent compounds, right? So you know that when here we have discussed sharing of electron, bond pair. So whenever covalent bond is there, electronegativity is there. So it is necessary to mention covalent bonding, right?
Yeah.
So
Yeah.
this electronegativity for 2 mark, right?
Yeah.
Power of an atom, power of an atom
All right.
to attract, power of an atom to attract bond pair of electron. This is for 1 mark, and for 2nd mark, in a covalent bond. In a covalent bond. So electronegativity It is the power of atom to attract bond pair of electron toward itself in a covalent bond. In a covalent bond.
All right, sir.
9701 October, November, variant 22, 2015, question number 1. So power of an atom to attract bond pair of electron in a covalent bond is called electronegativity. Now name and describe the type of bonding you would expect to find between particles with equal electronegativity. Yes.
This will be covalent, right? Because like it's polar. Oh wait, no, sorry. It's non-polar, and that means
It's non-polar.
polar.
Exactly, because difference of electronegativity is 0. So delta electronegativity is equal to 2.2 minus 2.2 is equal to 0. So
Which is non-polar. So then we're gonna describe what the definition of covalent is. Covalent bond.
Name and describe the type of bonding you would expect. Exactly, covalent bonding. Exactly. This is for 2 marks, right?
Yes.
So first is covalent bonding. And then describe what is covalent bonding.
It involves like the sharing of electrons, and it only happens between two nonmetals.
Exactly. No need to. Yes, you can say that between two nonmetals. Yes, but the covalent bonding in which electrons are shared, in which electrons are shared. Electrons are shared. Covalent bonding in which electrons are shared. Now, next question.
It's probably ionic, right?
Maybe ionic. Okay.
It's
name and describe the type of bonding you would expect to find between particles with very different electrons. Maybe ionic, maybe polar covalent, right? But mostly ionic.
Yes.
Because very different values. So very different values means ionic. Ionic bonding. For example, NaCl. Now, can you tell me the electronegativity of sodium? Can you find? Chlorine is 3. Can any one of you find the electronegativity of sodium?
Oh, 0.93, sir.
Yeah, 0.93.
0.93. Now find delta electronegativity, right? Now subtract both.
2.07.
2.007 means most very ionic. So very ionic because it is greater than 1.7. So ionic bonding, this is for the 1 mark, and second mark to explain what is ionic, right? So electrostatic force of attraction, electrostatic force of attraction between cation and anion. Between cation and anion. Okay. Do you have any question regarding this electronegativity?
No, sir.
Okay. Now I am finding more question. Nine seven zero one variant 22 February March 2023. Question number one. Question number one. Question number one. Oh. Now 9701 October November 2023. Paper 22. Oh, February March. Sorry. February March. Variant 22/23. February March 23, 22. Yes. Where is 22? 22. Yes. Yes. This is very, very important question, right? Very, very distant question, right? Okay. Pauling scale is given. Pauling scale is given. Now Pauling scale is given. Now define electronegativity. Yes, what is electronegativity? Can anyone repeat it again?
Power of an atom to attract a bond. Electrons to itself, and that's like covalent bond.
In yes, exactly. In a covalent bonding, right? Power of an atom to attract bond pair of electron in a covalent bonding. So oxygen and sulfur are in group 16. Explain the difference in Pauling electronegativity of oxygen and sulfur. Yes. For 2 marks.
So I don't really know how to go about this.
Okay.
Yeah, how do you construct an answer? Like, what do you compare?
Pauling electronegativity of oxygen and sulfur. It means across the period. You know that oxygen sulfur are across the period, and you know how to write the answer.
So do we say that like oxygen has more electronegativity?
No. You can say that. Now look at the periodic table, right? First, look at the periodic table, right? Either oxygen sulfur down the group or across the period.
It's across the period.
So across the oxygen and sulfur across the period. Are
Wait,
you
wait,
sure?
so
Or
no,
down
I'm
the
not.
group?
Well, let me see. I think it's down the group. They're both in period. I mean, sorry, group
Okay.
16, right? And then down.
Down the
Okay.
group.
So down the group. So down the group size increases.
Uh, yeah, the number of shells increase.
Number of shell increase, no?
Mm-hmm.
So
That reduces electronegativity.
so electronegativity increases, decreases,
Decreases.
decreases. So can you repeat the answer again? Or any 2 points? Any 2 points?
Like basically, since they are just going down the group, the shells like increase, which reduces electronegativity.
Down the group shell increases, nuclear attraction decreases, shielding increases. Are you getting my point? Hence, nuclear attraction, as the nuclear attraction decreases, pull of the electron also decreases. Hamza, can you repeat?
Wait, sir, I didn't catch the last part. Could you repeat that?
No, yes, repeat. Now look at the periodic table and tell me the position of oxygen and sulfur. Either both of them are across the period or down the group. Right?
They're down the
So,
group.
down
Yes.
the group. So, which element has smaller radius?
Oxygen.
Oxygen. So, oxygen has a smaller radius, less shielding, more attraction. That's why electronegativity of oxygen is greater than electronegativity of
Sulfur. Got
sulfur.
it.
Right? Can you repeat the answer again?
Yeah, sure.
Hmm.
So oxygen is higher than sulfur. Sulfur is further down the group than oxygen. As a result, oxygen's radius is smaller, and it has comparatively less shielding, the shielding effect, which therefore means that the electronegativity of oxygen is greater, right?
Very good. So it is all about the size, right?
Yeah.
So I need your help. So which one has less shell?
Oxygen, sir.
Oxygen. So size of oxygen atom is smaller than size of sulfur, right? Size of sulfur. So size of oxygen atom is smaller than size of sulfur. Number two, less shell, less shielding of electrons in oxygen than sulfur. Now third point, oxygen has more nuclear attraction, than sulfur. then sulfur. Are you getting my point or not? Yes, beta.
Yes, sir, I got
Yeah,
your point.
Okay, Alhamdulillah. So I'm trying to find more question. Okay. Which of the following statements are correct for the sequence of the compound below? Between the element in each compound increases the formula. Now next question is 9701. May June 2003. Question number 34. Now look at the question. It's 2003. 2003 May June. Paper 1. Question number 34. Yes. Which of the following statement are correct? Yes. Which of the following statement are correct for the sequence of the compound below? First point. Electronegativity difference between the elements in each compound increases. Yes. Is it correct? Are you listening my voice?
yes.
So this is across the period. So which one has more electronegativity? Silicon or sodium? Are you getting my point or not? Are you listening? Hamza?
Sorry, yes, I
Hamza,
can.
statement 1 is false, right?
Sorry,
It's
what's that now?
false because sodium fluoride has the greater difference in electronegativity. It's not increases. You know that sodium fluorine has maximum highest electronegativity. So one is wrong. Statement 1
Yes,
is
sir, this
wrong.
is wrong.
Why? Because
Fluorine.
fluorine, because sodium fluoride has greatest difference. Greatest difference in electronegativity. Why? Because one is group 1 and second one is group 7, right? So this is group 1. This is as group 7, 17. So you know that group 17 has highest minus group 1 which has lowest. Now tell me Will you obtain the lowest value or highest value? Yes, Raina. Daniel, are you listening to us? Mohammed.
Yes, I am. I don't really understand the second
Now,
statement.
listen. No. First statement. Group 17 has the highest, and group
Yeah.
1, you know that the lowest. So the difference is maximum. Now the
Yes, I
second is
understand.
that, okay. Now the formula unit of these compounds are isoelectronic, have the same number of electron. Now, can you tell me the number of electron in sodium? Sodium has 11 electron. Fluorine has 9 electron. Are you listening my voice or not?
Yeah, so this statement is
The formula unit of these compounds are isoelectronic. Sodium has 11 electron and fluorine has 9 electron. Am I right or wrong? Oh, are you listening my voice or not?
yes, sir. Statement is
20
wrong.
electrons. So 20, right? Now magnesium plus oxygen. Magnesium has 12 electron, oxygen has 8 electron. So again 20. Now aluminium plus nitrogen. Aluminium has 13 electron, nitrogen has 7 electrons, so again 20. Silicon plus carbon. I think silicon has 14. Silicon has 14. Can you confirm? Silicon has 14 electron.
Yes, it has 14.
14. So this statement is correct.
Oh.
Now the last is the bonding becomes increasingly covalent. Yes. Because group 1 is ionic, group 2 is ionic, and the remaining are covalent. So this statement is correct. Group 1, group 2, ionic, group 13, 14, covalent. Do you have any question regarding this one? Electronegativity?
No, sir.
Okay. So inshallah, from the next class, we will start new topic, right?
All
Allah
right, sir.
Hafiz.
Hafiz.
Allah Hafiz.
Also, sir, could you just upload the notes, please,
Hafiz.
of this chapter and the previous?
Inshallah, by tonight, inshallah, I will share.
Thank you, sir.
Allah Hafiz.